The problem is make an AP. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. Chef has a strictly increasing sequence A of length n that he wants to convert into an arithmetic progression. Now in one operation, Chef can choose some integer and then insert it anywhere into the array. We need to find the minimum operations required for Chef to achieve his goal. It can be proven that it is possible under the constraints of this problem. We call a sequence A of length n a arithmetic progression if the difference between ith element and its previous element is constant for all the values of I. For example, 1, 3, 5, 7, 9. This array has arithmetic progression because the difference between each adjacent elements is 2. Difference between 3 and 1 is 2, 5 and 3 is 2, 7 and 5 is 2, and so 9 and 7 also 2. The input format is that we have t test cases, and for each test case we'll have two lines. The first line will contain the integer n, that is size of the array, and the second line will have n integers a1, a2 till an. As for the output, we simply have to output the minimum operations needed for Chef. The constraints of the problem are as follows. Number of test cases will go from 1 to 100, length of the array will go from 2 to 100, and value of the elements themselves will go from 1 to 10 raised to 9. And since the elements are strictly increasing in the array, ai is always going to be less than ai plus 1. Let's see some sample inputs. So for the first sample input, the array has the element 1 and 3, and the difference between them is 2. So this is a proper arithmetic progression. Therefore, no steps are required. Next up, we have 1, 7, and 9. If we see, the difference between first two elements is 6, and second between the other two is 2. So we need to make sure that the difference between all the terms are same. So what we will do is, we'll insert two terms. We'll insert 3 and 5. And with this, the difference between all the terms, adjacent terms, become 2, as we have seen in our example. So with this array is now in arithmetic progression, and we needed to add two elements. Therefore, the answer is 2. Similarly, we can check for other sample examples. Let's see how we can approach the solution. Let's assume that we have this array and we have the elements a1, a2 till an. Since we know that all the thing that is required here is that the difference be same. So let's say the difference between adjacent elements that we have is x, y, z, and so on. Now if this difference is already equal, our answer is simply 0. But if they are not equal, what we need to do is, we need to divide them in such a way that they do become equal. So if we have x, y, and z here, we need to find a common divisor, because only with the common divisor can we divide them into equal parts, and it will be in such a way that all the difference be equal. Now since we need to do this in minimum number of operations, the divisor has to be as big as possible. So we have a term for that, that is greatest common divisor. So what we can do is, we can simply find the greatest common divisor among all the values of differences, that is in this case x, y, and z, and so on. Once we have this GCD value, let's call it the divisor d, we know that this is going to be our arithmetic progression term, that is, this is the difference going to be between each adjacent elements. So what we can do is, we can find the total number of terms. Since the array is increasing, the total number of terms is nothing but first and last element difference. So this is our total number of terms, that is difference divided by d. So you can think of it as steps. So the last number and the first number is the range, and we know that we are going to add elements that will differ at d. So this gives us total number of terms that are going to be in this range. And since we already have n terms, we can subtract that and get the number of terms that we have to add. And this will give us our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of our array. And once we have that, we'll go over the adjacent elements, get their difference, and find the GCD value. So we initialize the value by the difference between first and second term. Once we have that, we calculate along the array to get the GCD value. That is the difference D. Once we have this, we know that this D is an incremental between each term. So we get the total number of terms. That is nothing but last element minus the first element divided by D. Now once we have that, we know the total number of terms. And from this, we'll simply subtract the number of terms that we already have. This will give us the number of terms that we are required to add to make the original array into an arithmetic progression. And as we can see, after printing this value, I got AC in C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and array, and calculate the GCD between differences among the adjacent elements. To calculate GCD, we import math and use the GCD function. Then again, we calculate the total number of terms in our range from first and last element. Once we have the total number of terms, we subtract what we already had, that is n. And with this, we get the number of terms that we need to insert into our array to make it into AP. And as you can see, I have AC in Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.